Good morning, everyone. Today is the session number one from the chapter of moving charges and magnetism, and this is an introductory session. Now, I have written here on the board. There are four bullet points which I have written on this board. So the first one is that in 1820 there was a Dutch physicist by the name of Hans Christian. So he noticed that the current in a straight wire produces a deflection in the magnetic compass needle which was kept nearby. That is, जब एक you notice that uh, the this magnetic compass needle got deflected when it was placed near a current carrying conductor. तो ये इसका पहला ऑब्जर्वेशन था. सेकेंड ऑब्जर्वेशन था कि ही नोटिस दैट when the direction of that current was reversed, then the orientation of the needle also got reversed. ठीक है, ये उसकी सेकेंड ऑब्जर्वेशन थी. एंड थर्ड was that the deflection of the compass needle increases on increasing the current or bringing the magnetic compass near that current carrying conductor. तो ये इसका थर्ड ऑब्जर्वेशन था कि what he did that he just kept this magnetic compass near that current carrying conductor, and when he kept that magnetic compass near that this current carrying conductor, the deflection of that that needle of this magnetic compass, it increased. ठीक है ना. And he also noticed that when the current in that straight wire was increased, then also the deflection of that magnetic compass needle increased. So these were the three important observations which he found in the year 1820. So in this chapter we will be studying that how the moving charge or the current which is flowing in a conductor produces the magnetic field. This is the first point. And how that magnetic field exerts the force on the this current carrying conductor. The third thing which we will be studying in this chapter is that how the particles can be accelerated to very high energies in the cyclotron. So these are some of the important things which we will be studying in this chapter. So now I have also written one important bullet point, that is the magnetic field follows the principle of superposition. That is the magnetic field which is developed by the by the current which is flowing in a conductor. It follows the principle of superposition. That is, magnetic field at any point. मैग्नेटिक फील्ड, इसका मतलब ये है कि मैग्नेटिक फील्ड, आई एम जस्ट राइटिंग इट इन ब्रैकेट में लिख रहा हूं, मैग्नेटिक फील्ड एट एनी पॉइंट is the vector sum of all the magnetic field due to the individual sources. ठीक है. So we have also studied in the chapter number 1, that is the electric field follows the follows the principle of superposition. In the same way, the magnetic field also follows the principle of superposition, and the principle of superposition says that the magnetic field at any point, uh, uh, due to a number of sources, is the vector sum of all the magnetic field ड्यू टू द इंडिविजुअल सोर्सेज. ठीक है ना. एक पर्टिकुलर पॉइंट के ऊपर जो मैग्नेटिक फील्ड की जो वैल्यू होगी दैट विल बी द वेक्टर सम ऑफ ऑल द मैग्नेटिक फील्ड्स ड्यू टू द individual sources. So it also follows the magnetic field also follows the principle of superposition just like the electrical field. So ये चार important point है. And now there is one more important point in this session, that is uh, yeah. Now the another important point in regarding this chapter is that we will be following two conventions during the course of when I will be taking the sessions in the coming days. तो दो कन्वेंशंस हैं जो कि इस चैप्टर को कवर करते समय हम फॉलो करेंगे. तो पहला कन्वेंशन ये है, फर्स्ट वन इज दैट द करंट या इलेक्ट्रिक फील्ड, इलेक्ट्रिक और यू कैन से मैग्नेटिक फील्ड, current, electric or magnetic field will be represented by a dot. ऐसे ये डॉट है, ऐसे रिप्रेजेंट किया जाएगा if this if the direction of this current, electric field or the magnetic field is away from the plane of a paper. Okay, will be represented by a dot if the direction of this current or the electric field or the magnetic field is away from the plane of a paper. Okay, we will understand about this concept in the forthcoming sessions. And this is the first convention. The second convention, that is here I am writing here as B, that is the current या आपका electric field or the magnetic field will be represented by a cross. इस प्रकार से क्रॉस होता है, will be represented by a cross if the direction of this current or the electric field or the magnetic field, the direction of this current or this electric field or the magnetic field is towards the plane of a paper. ठीक है. So these are the two conventions which will be following during the course of the forthcoming sessions. And the first convention is that the current electric field and the magnetic field will be represented by a dot. ठीक है, ये इस प्रकार का सिंबल होता है. If the direction of this current electric field or the magnetic field is away from the plane of the paper, and the current the current or the electric field or the magnetic field will be represented by this cross if the direction is towards the plane of the paper. So these are the two important conventions which will be following during the course of our forthcoming sessions. And so in the next session, that is in the session number 2, we will be discussing about the first most important topic, that is the Lorentz force. So thank you very much for joining this session, and probably maybe today itself I will be uploading the session number 2 on the Lorentz force. So thank you very much and have a nice day. Bye.